I'd like to give you a new and important way to think about technology in the future. In the last century, Western civilization transformed from an industrial-based society to an information-based society. But today we are on the brink of a new age, the age of human augmentation. In our business and national defense, it's imperative that we embrace this new age, lest we fall behind our strategic competitors. Technology can create superhuman capabilities. By that I mean the combination of human ingenuity and machine efficiency and power and speed can combine to create capabilities that are more than human. Over the coming decade, we will achieve new levels of such human-machine teaming, and we'll see unimaginable new capabilities as a result. In 2001, a new type of cancer drug made the cover of Time magazine. The innovation of these drugs was underpinned by the Human Genome Project, which took 13 years using the world's fastest supercomputers to map out all the base pairs that make up human DNA. Further biotechnology research dived deep into the complex communications mechanisms within the human cell. One of these drugs, called Gleevec, blocks an enzyme that tells a cancer cell to grow, called a tyrosine kinase. Gleevec was first used to treat leukemia patients. Later, it was discovered to be effective against another type of cancer, a rare gastrointestinal cancer called GIST. In 2012, Gleevec was approved to treat GIST cancer. I know this because in 2013, just 1 year later, I was diagnosed with GIST cancer. And if it wasn't for this bit of technology, I would not be here today to give this speech. That is truly superhuman. Technology can create new and powerful ways to grow. And there are many examples of this age of human technology, human technology. One of the things that we see is that humans and computers are finding new ways to team. This age of human augmentation is being driven by two forces, the exponential increase in the rate of technology and the convergence of multiple technologies to create new capabilities. Let me give you a few examples. This is the stunning Elbphilharmonie. This concert hall was started out as a simple sound map designed by acoustician Yasuhiro Toyoda. Fortunately, we have new tools in the toolbox to do human-computer interactions, the tools of parametric, algorithmic, and generative design. Although this started out as a simple sound map, it was done with the help of a computer. Every element of the size and shape and structure of this concert hall is unique. In fact, there are more than 10,000 acoustic tiles in this concert hall. Each one is a snowflake, specifically designed to achieve the sound map laid out by Mr. Toyoda, shown here pointing to one of those acoustic tiles. Superhuman. Another example is this motorcycle swing arm. This was done with the help of a generative algorithm. These type of genetic algorithms take only the most basic inputs from a human. And using trial and error and digital testing and elimination can develop something based on only the broadest of inputs. Perhaps you tell it what the loads you want are, the envelope that it must fit in. And a computer will design this. Coupled with another emerging technology, additive manufacturing, this technology, this swing arm could be produced in a way no human could have done individually. Technology can also create a superhuman workforce. Today we send individuals to schools to learn in groups with set objectives and standardized curriculum. But imagine if we could use technology to identify early on in a student's career their aptitudes and propensities and their probability to learn, And you could define an individualized curriculum designed specifically for them to take advantage of those skills. And using technologies such as augmented reality and virtual reality and nerve stimulation, you could put that individual into a state of flow where learning is optimized and retention is maximized. Now imagine if you had dozens or hundreds or thousands of such individuals. Using algorithms and analytics, you could take a subset of those individuals, each with a unique skill print developed through this process, or according to my friend and futurist, Dr. Gabriela Rizzo, a sculpture. This individual could be shaped into somebody with very high performing potential. And if you took a subset of these folks and put them towards a team to solve a particular problem or to perform a new duty, that team would likely achieve superhuman results, at least compared to our traditional way of training and teaming. That is superhuman. IBM's Deep Blue beat Garry Kasparov at the game of chess by looking tens or hundreds of thousands of moves ahead. IBM's Watson beat Ken Jennings at the game of Jeopardy by having petabytes of information at its disposal. Google's AlphaGo beat the world's best players at the incredibly complex game of Go by studying strategy from the world's best players. But I'd like to talk for a second about a subsequent piece of hardware or software called AlphaGo Zero. AlphaGo Zero differed from its predecessors in that it was not, AlphaGo was taught the game of strategy by looking at the best human players. But AlphaGo Zero was not told strategy at all. In fact, at the beginning, it only knew the rules of the game. It played games against itself using reinforcement learning until it could anticipate its own moves. And eventually, after thousands and thousands of games, could understand how those moves would impact the outcome of the game. After 3 days and millions of plays, AlphaGo Zero was able to beat AlphaGo. After 21 days, AlphaGo Zero was completely unbeatable. It developed new and innovative strategies, some of which we don't even understand. And that is a little bit scary. Sometimes machine learning algorithms reach their objectives in ways that we don't necessarily comprehend. We must be careful of this. But imagine if we use this technology, these capabilities wisely in our military systems in force design. It could be a force multiplier. If we find ways to bring decisions to humans, technology can produce superhuman decisions by giving us a broader selection and a wider array of decisions than a human could come up with alone. Let the AIs crunch the possibilities and let the humans do what humans do best. Resolve ambiguity, apply judgment, morality, and ethics. The results would be superhuman. We should be and we will be applying artificial intelligence agents to our war games, both on the blue side and the red side. We will find ways to bring AI-informed data to our commanders and decision makers so that they can crunch the possibilities and develop strategy and tactics that no human could do. And this will extend to the battlefield, where commanders and decision makers will have at their disposal multiple autonomous agents, each able to autonomously control the execution of things like reconnaissance or fire control or attack. And we must think carefully about the ethics of this and how we will trust these autonomous agents, especially in an era of lethal autonomous warfare. But I assure you, our adversaries are developing these technologies, and we simply cannot afford to lag in this area. The possibilities are boundless. AFRL is at the forefront of pushing the exponential growth of these technologies and the convergence of these technologies. and you are creating new superhuman capabilities. I'm inspired by your work, and I commission you all to continue to lead us into the age of human augmentation.